In this video, we're going to work on using prime factorization to find LCM, or least common multiple. So just to review, least common multiple means the smallest multiple that two numbers have in common. And just like when we were using this process to find GCF, the first thing we are going to do is we're going to find the prime factorization of each number. Prime factorization means when we break down the numbers to its factor string that is only prime numbers. So for example, the prime factorization of 4 is simply 2 times 2 because 2's are prime numbers. A 2 is a prime number, and 2 times 2 is 4. So the prime factorization of 4 is 2 times 2. And then our prime factorization of 21 is 3 times 7. And that one's pretty simple too because both 3 and 7 are prime. Now to find the least common multiple, what we're going to do is we need to find a factor string, and we're going to go ahead and write that down here. We're going to find a factor string that would include a 4 and a 21. So we're just going to start with each factor. So let's start with a 2. So I have 2's over here, but I don't have any 2's in my 21. So let's just go with, what do I need to make a 4? Well, I need 2 2's. So in order to make a 4, I need a 2 times 2. So I'm going to go ahead and put that in my factor string for my least common multiple. Then over here, what do I need to make a 21? Well, I need a 3 and I need a 7. And this one's pretty simple because there are no overlapping factors between each prime factorization. So to get the 4, I need a 2 times 2. To get the 21, I need a 3 times 7. So all together, to get the least common multiple, I need all of those factors. So let's go ahead and solve. 2 times 2 is 4. 4 times 3 is 12. And then if you're not sure what 12 times 7 is, you could go ahead and just work it off to the side real quick here. I'm going to double check my mental math. And 12 times 7 is 84. So the least common factor is 84. Now think, does that make sense? If I did all my multiples of 4 and I did all my multiples of 21, would the smallest number where they meet up, would it be 84? It would, because if I just even looked at my multiples of 21 right now, remember multiples are skip counting, I would get 21, 42, 63, and 84. And the first one of those that 4 goes into is 84. So it makes sense that my least common multiple is 84. All right, let's try another one. And this one does get a little bit more complicated, so stick with me here. It can be a little bit confusing. So let's go ahead and just start with our prime factorizations. I can break 8 into 2 times 4. And then 4 isn't prime, so I'm going to break that into 2 times 2. And then I'm going to bring this 2 down because 2 times 2 times 2 is 8. And then I'm going to come over and find my prime factorization of 12, which is 2 times 6. And then I'm going to break my 6 down into its prime factors of 2 times 3. Pull that 2 down because 2 times 2 times 3 is 12. All right, so the reason this one is a little bit more confusing is because this time we have some overlapping factors because I have 2's over here and I have 2's over here. So I need to think, do I need to use 2 2's in my least common multiple, or do I need to use 3? The answer is I need to use 3. I need to use the most of whatever factor I'm looking at. So the most 2's I have is over here. The reason is because 2 times 2 times 2 is 8. So if I used 3 2's, I get 8. And if I were to only use 2 2's, I would get 4. 2 times 2 is 4. And I need 8 to go into my least common multiple. So I need to use 3 2's in my least common multiple. So I want to pick the most amount of each factor. So I should have a 2 times 2 times 2 down here, and I should have a 2 times 2. And I do. So since all of these are covered down here, then I'm done with my 2's because they're covered. So I have 3, and within the 3 2's, I have 2 2's. So that's covered. And then the next thing I need to look at is my 3's. And that's pretty simple because I only have 1 3 over here. If I didn't include the 3, I would not get the 12. So I have to include the 3 in my least common multiple. So another way to look at this, guys, is that each prime factorization should show up in your least common multiple. So for example, here's my 2 times 2 times 2. I'm going to circle that in that kind of purplish color. And then let me show you where my 2 times 2 times 3 is. That's right here. So they overlap, but they're both in there. And that's what we're looking for. So let's solve this out. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Does it make sense that my least common multiple is 24? Yeah, because 12, if I did my multiples of 12, I would get 12, 24. If I did my multiples of 8, I would get 8, 16, 24. So doing it the old way, I can check to see that yes, the answer is 24. All right, let's try one more here. We're going to try 9 and 30. So I'm going to do the prime factorizations of these pretty quick because that's a skill we've worked on quite a bit. So let me just get these prime factorizations down. So the prime factorization of 9 over here is 3 times 3, and the prime factorization of 30 is 3 times 2 times 5. All right, so I'm going to start with my 2's. I have 1 2 over here, so I have to include it in my least common multiple. Then 3's, I have 1 3 over here, but I have 2 3's over here. So I'm going to include 2 3's because otherwise I wouldn't have a 9 in my prime factorization, or I'm sorry, in my least common multiple down here. So by including 2 of them, this one's already included. So we're good with the 3's. I'm going to cross those out, and then I'm going to go back and cross my 2 out. And then 5, I have 1 5 here, so I have to include my 1 5. So if I look at that again, let's see, do I have a 3 times 3 in there? Yep, it's right there. And then do I have a 3 times 2 times 5? Yep, it's kind of like all over the place here, but there's my 2 times 3 times 5. So let's go ahead and solve. 2 times 3 is 6. 6 times 3 is 18, and then I'm going to do some math over here for 18 times 5. That would be 90. So my least common multiple for 9 and 30 is 90. Now, if this skill feels shaky for you right now, it's okay. This is a hard skill. This is a skill that takes a while to get down, especially when we pair it with finding GCF using prime factorization. It gets kind of confusing to go back and forth between the two skills. So stick with it, keep practicing, you got this.